find all the permutations of given string. So suppose we have a string of ABC, and we will output all its permutation in a set which contains all the strings of its permutations. So first, we want to make some clarifications that our given input string shouldn't be null, and if the given string is an empty string, we will output a set of empty strings. So from the high level, we're going to solve this problem with recursion way and recursion method, and our recursion tree should look like this. So we're given a string of ABC, and we have the level number as the character numbers. So for the level 0, we will swap the character which has the index of 0 with itself and with the characters who has larger indexes. So in here we swap with itself, and we swap with B and C. And for the next levels, such as level 1, we start from the character with index level 1, which is B, and we swap itself, and we swap with the characters on its right side. So on the last level of this recursion tree, we will have all the permutations as their leaf node. So for coding, we are going to use the function use the string input as the function input parameter, and we will output a list of string as the result. And so we need to initialize the list string as a result, and we transfer the string to the character to the char array, and we initialize a index start from 0, which represents the level of the recursion tree, and we illuminate the corner case we just discussed, and we need to call up a helper function to get the recursion, and we have this our helper function with input of all the parameters we just initialized, and for the base case of the recursion, the base case should be on the last level of this recursion tree, which means the level, the index should be the same number as the char array's length. And if that's the case, we need to build a new string to store the solution and add the string to the result. If it's not in the corner, if it's not in the base case, we need to swap the current character with the other character, and then we goes to the next level, and then when we finish and come back, we need to swap it back. So this is what we did in this part. For the time complexity, we have it's dependent on how many nodes the recursion tree has. So we have n nodes in the first layer, and for every node on the for every node when it goes to the second to the next layer, it has n n minus 1 nodes as child, n minus 1 child nodes. So for the next one, for the last layer, it should has 1. So we will have a n to n. We will have a O nth factorial of time complexity because every node has a O1 complexity. And for, this is time complexity. And for space complexity, we need the height of the recursion tree. So it should be the number of the character in the string. So it's also it should be O n.